this would be rather difficult to grab. If we come in here and say list the results for all the nodes, well, we've got 53,000 nodes in the model, and it's difficult to say, you know, where they all are. Now we could sort them by the original XYZ locations, and you could filter it that way. But what's much easier is to graphically, if you were interested in deformations, say along the main deck, an easy way to do that might be to create a nodal group. And what we would do is come in here and create a nodal group, and we will say all visible nodes. And in order to do that, let's reduce what we're seeing here. We'll first make a general group. We'll grab one element, grab the seeds, or actually, since we have a main girder that runs the full length, it would be very easy to just grab that main girder and make a group. So the easiest way to do this might be from grabbing that girder. So what we will do is make a general group, add by seed on that girder. So now we have the full length of the ship, that girder along the full length of the deck. And if we create that group, well, the easiest way to convert it to nodes is simply drag it to be a nodal group. This is the centerline girder. If I move that to the nodal group, now we have a string of nodes along the center of the main deck. And if that is my current view part, now I can come into the list results and say list nodes. And now I have all of my dx, dy, and dz deformations for only all of those nodes along the center line on the main deck. And I can sort them by x. So you can see each meter along the length. I've got my dy, my vertical displacement, running down the length of the ship. So you could just grab this, copy it into Excel, and generate a plot of the vertical deformation along the length of the main deck on center line. Both nodal and plate groups or general groups are really useful for combining with this results list nodes and elements dialog. And in fact, we used this for that dry dock project where the ship was being repaired. When we were interested in what the displacements were, we not only used it for the deformations on the wing wall of the floating dry dock, we also used it for portions of the ship where they were removing plates. We created a nodal group around the boundary that was being removed, and we could measure those displacements of the ship on the blocks before they removed the plate, and then we removed the plate, reran the analysis, and measured the displacements on that group of nodes on the perimeter with the plate removed to see how much the plate would shift before and after they cut that part of the hull away. All those were combined in a spreadsheet. We just used a large lookup table to find all of the appropriate nodes, compare them, but it was all through this dialog here where we just plotted our predefined nodal groups for those boundaries, listed them, copied them into Excel, and compared them before and after, and it worked quite well.